Everyone, welcome back to my channel, Monk in Cloud. In this video, we are going to see how to create an AWS RDS instance using Terraform. So we are going to create a PostgreSQL database in the RDS instance, and we will also try to log in to the RDS instance using the EC2 instance. All right. So without wasting much time, let's get started. So all the source code, all the things that we are going to do in this demonstration have been documented, and the link to the GitHub repository will be in the description. Please check that out. So this is a full-fledged code. You don't have to do anything at all. All the things that are required is you just need to have the instance connect. Once the EC2 instance is up and running, just connect to that instance and connect to the RDS database inside this EC2 and see if it is working or not. So the cool thing about this project is that we are also going to include the read replica. Most of the tutorials online have not included the read replica for the RDS databases. We are going to do that. And if you're wondering what is the architecture that we are building, this is the one. But before that, let me give you the background on what is going to happen. So ignore this part. We are only going to use two availability zones. Okay. So this is the landing zone that we are going to build. If you have not watched the landing zone video that I've created previously, please check that out. I've explained all the things in detail with the code, with the demonstration. So we are going to create only two availability zones, and we are going to create one public subnet and a private subnet in each availability zone. So if you're wondering where our RDS database will be, it will be in the private subnet, and our EC2 instance will be in the public subnet. Okay. So we will have the communication between the public subnet and the private subnet, and hence all the EC2 instance or the compute that is present in the public subnet will be able to reach out to the private subnet. Right. So it is one of the secured way of connecting. I will show you how is the security group is configured and all those things. But this is just a high level diagram or the architecture diagram for this particular project. Now let's go to the RDS database itself. So as I told you, we will have two private subnets, and I've just removed all the unnecessary things that comes under VPC so that it will be clear for RDS itself. So here we will have two availability zones, and in that we are going to create a database, RDS PostgreSQL database. For that database, we will create subnet groups, we will create parameter group, we will also create a logDB parameter. All those things we will create, and we will also create a PostgreSQL read replica for the same database. Let's say if this database goes down for some reason, we will have a read copy of that. And if you want, you can make this as a primary database. So what is primary database? Usually we will be interacting with this database. Let's say if this goes down for some reason, so then we can make this as a primary database, and we can able to achieve all the things that we do with the primary database. Okay, so I hope you understood the architecture that we are trying to build. And now let's go ahead and see the code for this one. So the code looks pretty simple. If you have gone through my previous videos, that would be really easy for you. So we have a few files that I've created. I'll explain all the things in detail one by one. So please bear with me until I complete it. So first thing is we have a file called providers.tf. If you have watched my Terraform videos, you would be knowing what is the use of providers.tf. In a simple way, it is going to have, let's say we are interacting with AWS, right? So what is a provider here? It is AWS. So we are going to use a provider called AWS here. And I'm going to use US East 2 as my region for creating all the resources. So that is what I've mentioned here. And in the same way, we are giving the Terraform requirements. So basically, what is the version of Terraform that you want? All those things I've specified here. And what is the AWS version, and all those things have been put in these 7 lines of code. Okay, now this is done, providers.tf. Next important thing that we need to understand is the main.tf. So let's go to main.tf. So what I'm creating here is, for all these things, the base is a VPC itself, the basic infrastructure that is required to create all the RDS instance, read replica, and everything is the VPC itself. So I'm creating a VPC with the name AMC VPC. This is just a logical name for Terraform coding, and I'm using tags here. I'll show you how I'm importing all these things in the variables. And cider block, I've used a variable called VPC cider. I will show you what is the value there. And I'm enabling DNS hostname is true, and enable DNS support is set to true. Now let's also check the variables.tf for vpc.cider. Okay. If you see here, this is the variable that I've created, and this is the network addressing for the default VPC. The type is string. I'm giving the cider range as 10.0.0.0/16. Okay. So this is our cider block. Now, the next important thing in these files is, after main.tf, it is public.tf. So let me go to public.tf. So what we are doing here is, let me go to the architecture diagram again. All the things that you see in the public subnet will be in the public.tf. So to make it clear, all the things that you see here in the public subnet, availability zone 2A and 2B, will be in the public.tf. For example, the route table, the NAT gateway for the communication, all those things will be in the public.tf. So let me go over that. So if you see here, we have a internet gateway that is created. That is the basic. After creating a VPC, the first thing that you need to do is to create the internet gateway. So I'm creating that here. What is the VPC ID? If you remember, in the main.tf, we created a VPC. And I am just referencing the same here. Okay. Tags, I'm using the tag that I'll show you in a while in the variables.tf. Next, already, as you know, we need two subnets, that is public subnet A and public subnet B. Okay. So let me go back to my code here. If you see here, I'm creating a resource called AWS subnet, and this is public A and public B. And where should I keep these subnets? It should be in a VPC called AMC-VPC. So that is what we created in the main.tf. And what is the cider block that I'm referencing for subnets.db? Go back to variables.tf. If you see here, this is a variable called subnets, and this is a type of map. It's kind of a dictionary, I would say, in the normal coding languages. And the default values that I'm assigning is, for A, it should be 10.0.1.0/24. And for B, it is 10.0.2.0/24. Okay. So that is what these two subnets have been created. Next, after creating the subnets, we also need an elastic IP, and that should be associated with the NAT gateway. If you see here, that is what we have. So what I've done is, I've created a elastic IP here for elastic A for availability zone 2A, and for B for 2B. Okay. And I've created the NAT gateway here. And if you see here, I've used a special function called depends on. What is this depends on means? And the Terraform will wait until this resources is created. So sometimes Terraform will randomly create the resources. In such scenarios, if you do not specify this, it will throw an error saying the NAT gateway, the elastic IP is still not created. So the Terraform script will fail. So instead of that, what you can do, you can add a function called depends on. Until this resource is created, it will wait, and only then it will go and create the NAT gateway. Okay, so that is what we are doing for NAT gateway 2A and 2B. So these are the NAT gateways 2A and 2B. Okay, I hope I'm clear on this. Next, we need a route table. So first we need to create a route table, then we need to associate a route table, and we need to have a route as well. So what is a route table? It is basically going to define what are the things, or whatever all the traffic can reach your subnet in the VPC, right? So this is what I've given. If you see here, I'm creating a route table for a route public subnet A, and the VPC ID remains the same. This is the required parameter. Then we need to associate this route table to a subnet. What is that subnet? Basically, this route table should be associated to a subnet. What is that? You already know the answer. This is public subnet. So what I've done, public subnet A. Okay. And the route table ID I'm getting from the this one. Okay, I just need to use AWS underscore route underscore table RT underscore public hyphen underscore A and ID. Similarly, I need to create a route. So basically, I need to define what is the destination side block, through which gateway it can reach. All these things I need to mention. As you already know, for the route table in the public subnets, the route will always go through via your internet gateway, and that is what I've defined here. And the destination sider will be quad 0. Okay, so it will reach via the internet gateway. And I'm doing the same thing for the route table B as well, or this availability zone 2B as well. Okay, so I'm creating a route table and I'm associating with this public subnet B, and then all the communication will flow via internet gateway that we have created. But if you are wondering how it happens with the private subnet, for private subnet we will create a route table. We will associate that route table with a private subnet, and communication will go via the NAT gateway. So that is the requirement. But if you always remember, the NAT gateway that you create, it should always be in the public subnet. That is a notable point that if you are in AWS, that is what you need to note. Okay. We have covered the public.tf. Now let's go to the private.tf. So all the things remain same. I'm creating a route table here, but before that, let me show you. I'm creating two subnets. Everything remains same. Whatever we discussed in the public.tf, everything remains same here. If you see here, I have a private underscore A, private underscore B. VPCI, it is same. Cider, I'm getting it from the variables.tf. Let me go over here. If you see here, private subnets. For A, I'm giving this value. For B, I'm giving this value. Okay, so I hope I'm clear on this. So I'm creating in the availability zone 2A for A. For 2B, it is availability zone 2B. Okay. Next, the thing is we need to create a route table. So this is what I've done here. And after creating the route table, we need to associate that to a private subnet. And that is what we are doing here. And after associating, we need to create a route. And I've done that. And as I mentioned, all the communication will go via the NAT gateway. But in the public, it was via internet gateway. So make a note of that somewhere. So all the things remain same for the private subnet B as well, right? So that completes our private.tf. Next, the very important thing here is creating the RDS database. So how have I done that? So in the RDS.tf, all I've given is related to the RDS itself. So now what we have done is we have created all the infrastructure that is required for creating the RDS instance. Now let me go through the architecture of this. We need to create an RDS instance. We need to create a subnet group. We need to create a parameter group and all those things. Also, we need to create a replica, read replica. So let me go over the RDS.tf. For creating an RDS instance, we need something called as DB subnet group, or a database subnet group. Basically, this the default subnet group for all the databases in your architecture. So what are the subnets that you need to give? It should be private subnets, because database should not be accessible outside of the internet, right? So I've given the private subnet A and private subnet B. And I'm giving a tag called environment is equal to dev. Whatever you want, you can give. Next, we need to create a parameter group as well. After creating the subnet group, the next thing that we need to create is a parameter group. So that is what I've created here. Let me close this off. Sorry for the interruption. So yeah, this is what I've created here. I'm naming it as a logdb parameter, and the family that I'm selecting is Postgres 16, and the parameter value that I'm giving is 1, and the name is log connections. Okay, so this is what it is. Next, we are creating the RDS database instance itself. So this is the block that is going to create the RDS database instance. So for all the databases, you need a username. So I'm giving a name called a Monkey Cloud. And skip final snapshot, I'm giving it as true because I do not want the final snapshot. And is it publicly accessible? I'm setting it to false because I don't want my RDS instance to be publicly accessible. Next, the password, I'm getting it from the variable called db_password. Let's go here. Let's search for db_password. password. This is what it is. This is the password of the database that we are creating, and the value is change me 123. Please make sure to change this value and make it sensitive so that it is not visible to anyone. Okay, but while you are storing these details in the repository, please be aware of that. It should not be disclosed in the repository. Next, we have a parameter group name. That is what we just created here, so I'm referencing the same here. Next, instance class, I'm selecting it from a variable. So let me copy this and I'll come back here. And if you see here, I'm using the variable called instance class, and the default value that I'm using is db.t3.micro. So this is what it is. So I've used that. Engine version I'm selecting as 16.1. Basically the Postgres SQL, the engine version is 16.1. Please make sure to check this before creating it, because the video that I'm creating is on 23rd of April 2024. It might change in future, so make sure to check it out. Okay, so I'm creating a default database called AMC by specifying it in a parameter called db_name. Again, engine, it remains Postgres. I've just given the same. DB subnet group, we just created that. I'm referencing the same here as well. Okay. Backup retention period, I'm backing up it for 1 day, so I'm giving it as 1. But in your production, if you want to change the value, please refer to the AWS documentation and then do so. And what is the allocated storage? I'm using 50 gigabits. So that is what I've mentioned here. Am I going to use multi-AC? Yes, that is why I've set it to true. And what is the security group that I'm going to use is I'm going to create that here below. So this is the security group. I'll show you what are the things that I've done in the security group. Okay, let's go over the security group now. So what is the name? It is db_sg. This is the security group for the database, RDS database that we are creating. And for this, we need an ingress rule, and I'm naming it as allow TLS IPv4. So basically, I'm referencing another security group, which is EC2 security group. So we have not covered EC2.tf yet, but wait for some time. I'll explain that as well. So I'm referencing a security group from the EC2, so that I'm just saying Terraform or AWS that allow only traffic coming from the EC2 and nothing else. That is the basic idea of referencing a security group. From which port I need to allow? From port 5432, because that is the default port for the PostgreSQL. And what is the protocol? It is always TCP. And the same thing, I'm creating a ingress rule as well, or egress rule. Basically, ingress corresponds to your inbound rules, egress corresponds to your outbound rules. So I've done the same thing, exact same thing, just that I'm allowing port from 0 to 65535. Basically, all the ports I'm allowing in the outbound rules. After creating the security group, I'm also creating a database read replica. I told you before that we will also create a read replica. If for some reason this database goes down, you can always use this database by making it as a primary database. All the things that we used, all the parameters that we used in the DB instance that remains same, except you need to provide one more thing called the primary database, or it will say replicate source database. What is the replicate source database? You need to mention the database instance that you created in the very first. So if you see here, this is what I've given, db1. So I'm using the same here. Okay, and I'm specifying it as publicly accessible, setting it to false. Parameter group remains the same, instance class remains the same. Identifier, I'm just naming it as, or identifying it by the name db and -replica. I'm backing up for 7 days and apply immediately. I'm setting it to true, right? So security group remains the same, whatever we created or explained in the previous step. So that completes the RDS database or RDS database creation. But how will you know if the RDS database is created fine, or how will you work with that? So for that, what I've done is I will create an EC2 instance in one of the public subnets. Let me go back to my previous, yeah. So we already know that RDS database instance lies here, right? What I'll do is I'll create one of the EC2 instance in this public subnet, and I'll try to reach out to this RDS database that we will be creating. So I will be trying to connect to the PostgreSQL and see if I'm able to connect or not, right? So that will complete our testing as well. So that is why what I've done is I've created a file called ec2.tf. So in this, what I'm going to do, I'm going to create an EC2 instance and the security group that is required for the EC2 instance. So that is what I've done. So in the very first place, what I've done is I'm trying to get the AMI for the EC2 instance by using a data module. So I'm going to use an Ubuntu image. So I'm going to fetch the AMIs available for my AWS account. This block of code works for all your AWS account as well. So basically, if I go to my AWS console, I'll open EC2. Under here, I'll go to AMI catalog. Here, if you see, we have n number of AMIs. So instead of using a random AMI, what I'm doing is we have a AMI called this Ubuntu server 22.04 LTS, right? What I'm doing, instead of grabbing this AMI ID and pasting it, so what I thought, I let this block of code works for all the accounts. So what I did, I created a data module and I'm fetching the AMI ID from the Terraform code itself. This block of code does that. Next, I'm going to create a AWS instance. So I'm naming it as a server, and the AMI that I'm using is data.aws_AMI ubuntu.id. That is what I'm doing here, right? I hope I made it clear. Next, the instance type that I'm using is t2.micro. This is just for testing. And subnet ID, it will be public subnet, as I told you. I need to create this in a public subnet. And associate public IP, I'm setting it to true because this should be publicly accessible. And security group, I'm giving this security group called EC2_SG. We are going to create that now. And the name for this server, name for this EC2 instance will be server. Next, as I told you, we are going to create a security group for the EC2. Basically, we are just allowing the communication from the EC2 instance to the database that we created. So the VPC will be remaining same. That is AMC-VPC. And that is what I've given here. Next is a security group ingress rule. Basically, what are the inbound connectivity that you are giving for the EC2 instance security group will be quad 0 along with from the port 0 to 65535. And the same goes with the egress as well, because I'm allowing all the communication on this EC2 instance. So this completes all the things that are required for your creation of RDS database in the private subnet, along with the read replica and along with testing if the RDS instance is reachable or not, right? So now let's do one thing. What I'll do is I'll just go to my terminal and I'll just click on, I'll just apply this and see if all the things are in place. So first what I'll do, I'll just clear the screen and I'll say Terraform init. So it should initialize the backend and it should download all the dependencies that are required. For example, the provider, all the things will be downloaded. And you will see a file called .terraform and .terraform.log.hcl. So if you open this, it will have the provider details and all the things in that folder. Okay. So let me clear the screen. We have seen that the Terraform has been initialized successfully. Next, let's see if the format of the Terraform is correct, or let's validate the Terraform scripts once. So if I've made any mistake, it will give me that Terraform validate. It says this configuration is valid. Next, let me just format the Terraform script. So basically, if I've made any mistakes like this, for example, IP protocol, I've given extra spaces and all, it will format in a single format and it will give it to me. So I'll just hit format. If you see now, it is automatically changed. Okay, now let me clear the screen. Let's go ahead and run Terraform plan and see what are the things that it is going to create. So let's wait for it to complete. So let's see and understand how many resources it is going to create. So if you see here, it has given the plan where it says 33 resources will be added, 0 to change and 0 to destroy. So it is going to create 33 resources. All the things that we discussed in all the different files will be created. So let me clear the screen. I'll go ahead and apply this script, and let's see if the databases will be created or not. So to apply this, we just need to run Terraform apply --auto approve. So refrain from using auto approve in your production, because that is going to destroy, or that is going to affect you. If you now see, it is creating all the 33 resources that it planned before. So it started creating the elastic IP, it started creating the VPC, parameter group. All the things are in creation stage. So it will take some time for all the resources to be created. So let's wait until all the resources are created, and I'll come back once everything is deployed. All right. As you can see, the apply has been completed and it has created 33 resources. And let's go back to our AWS console and see if everything is in place or not. So let me check the VPC first. Let's go to VPC. All right. Let's go to VPCs, and here if you see, this is the VPC that we just created. I'll just go to resource map, and if you see here, we have US East 2A and 2B with one public and one private subnets each, along with the route tables configuration. So this is good. Next, let's go to RDS and see if the RDS databases is up and running or not. So let's go to databases. And if you see, this is our primary database, and this is our read replica. So you can see that here, this is our primary and this is our replica. The engine is PostgreSQL, and this read replica is in 2A, and the other one is in 2B. So as you remember, I have set multi-AZ to yes for the primary database, and yes, it is taking that as well. Let me open this. And if you see here, this is the database endpoint, this is the availability zone, this is the VPC. These are all the subnet groups that we provided. This is the VPC security group. Let me open that and show it to you. Okay, so this is the security group that we just saw. And replication, we have one primary and one read replica. The replication source is this one, and the status is replicating. Okay. Next, let's go and see monitoring. There will be CloudWatch setup and everything will be monitored. Next, go to configuration. If you see here, this is a database instance ID. Engine version is, if you remember, it is 16.1. The DB name that we created is AMC. Let me go back to my Terraform, RDS, and all the way to the instance here. If you see, our DB name is AMC, and that is being created. And the PostgreSQL is 16 version. The instance class is t3.micro. All the things are in place, even the multi-AZ, the logs are being in synced, all the things are in place. Now the actual testing comes in, but before that, let me also open the security group for you. Let me open that. Let me scroll this a little bit. Let me open the security group. Let's check the inbound roles here. If you see here, the security group ID is this one. The type is PostgreSQL. And the port range is this one. And the source, source security group this is from the EC2 instance. So let me just copy this, and I'll also go to instance. I'll open the instance. I'm basically allowing all the traffic from the EC2 instance which are redirected to the port 5432 alone. Okay. So let me go to EC2. This is the server that we just created. Let me open that. I'll go to security. If you see here, let me see, this is the security group, and that is also being present in the DBSG, right? So now what I'll do is I'll just connect to this EC2 instance using EC2 instance connect method. and I'll execute some commands. I'll install PostgreSQL and see how it goes. Okay, so this is the command to install PostgreSQL. Sudo apt install -y PostgreSQL. Because I'm using Ubuntu, it is apt get. If you're using any other flavors of Linux, make sure to change it accordingly. For RHEL, it will be yum, or for Debian based instances, it will be apt get. Right? So after that, you need to connect to your PostgreSQL using this command, psql -host. You need to provide the RDS endpoint here. Okay, so I'll show you that. Port remains same, that is 5432. Username you need to change, and the password and the DB name you need to change. Let's do that later. First, let me log into the instance and I'll install the PostgreSQL. If you see here, this is the EC2 instance console. I'll just clear the screen and I'll say, first let me update the system, right? Sudo apt get update -y. So let's just update the system, just updating all the things. Let's wait for it to complete. Okay, the update is in place. Let me just clear the screen. Now let me just go ahead and type the same command, sudo apt get install PostgreSQL. So I'll hit enter, and if you see, it is getting all the required details. Let me give some time. All right, I think it is creating all the necessary things. It is also installing the PostgreSQL. Let's give it some more time. Okay, now it is done. Let me clear the screen. So what I'll do is I'll just copy this command. Okay, so I'll just open my readme.file. Okay, so let me come over here. I've just pasted the same here. Instead of this host, you need to replace it with some other value. So I'll just go to my RDS console, and here if you open the first one and let's go to connectivity and security, you will see endpoint. Just copy this by clicking on this button. Let me just replace this with the one that we copied. Port remains same. Username, I believe it should be, let me go back to rds.tf. Username is a Monkin Cloud. Let me just copy that. I'll come to readme.md. Okay, where is that command? Here it is. I'll just paste that. Password is fine, and the database name is AMC. So let me just copy this. Come to my AWS EC2 instance. Okay, let me just paste that command and I'll hit enter. So it is asking me for password. So password, if you remember, I'm getting it from the variables.tf. I'll go over here. Where is the password? So here it is. Change me 123. I'll just paste that and I'll hit enter. If you see here, I was able to connect to the PostgreSQL, and right now I'm using AMC as the databases, right? So this is how you connect. First, you are creating a database, RDS database, and for that database, you are also creating a read replica. And after that, you are going to create an EC2 instance in the public subnet, and you will connect to that database using the PostgreSQL command, right? So this is one way of testing. But if you want to go ahead and use a client tool like dbvr or anything like that, you can also do the same thing here as well. But I prefer this one because most of the time we will be connecting from an instance or an application which is running in an EC2 instance to the database that is present in the RDS. So this is another way of testing. I hope you enjoyed learning along with me. I just wanted to cover this aspect in one of the video. So if you're liking the content that I'm creating, please consider subscribing and share it among your friends. Thank you, and I will see you in the next one with amazing content in the flow. Bye bye.